We'll go. Oh, there it goes. Okay, so just to outline what we're going to be talking about today, we're going to go over our high-level customer goals and also our recs and specs, which we have revised between the Arizona competition and the Carolina competition in the fall. Then we'll go over some background and observations, things that we've noticed about the car that we want to change or improve. Our plans for what we're going to change. We're going to talk about the front drive system, which we discussed in the previous PDR, and now we've made some decisions and we're moving forward with some design changes. Then we'll go over a few things related to the gear case and input shaft because we've had some issues regarding that. And then we'll talk about some simulation analysis that we have completed and need testing that we need to do. A lot of it will happen this spring. I'll give a few updates on the hubs design that I talked about in the last PDR. And then Lucas will present about our transmission, our CVT, and Bryce will present about power distribution.
Starting out with our goals, we have our high-level customer goal, which you've probably heard from the other PDRs, but with our first point of adaptability, we wanted to make sure that our CVT tuning had measurable tunings so we could change things like belt tensioning, the secondary spring, and then so we could predict the performance and better understand the system overall. And also that our universal joints or U joints must be able to fully accommodate for the range of motion for steering and suspension. And we're currently considering future changes for this, which we'll go over later. And then the second point is serviceability. So this means that we want to have more ease of removing the guarding. And then we're going to make sure, or we're going to verify this by doing it in the CAD and then also in the actual car. And then finally, for the U-joint assembly, U-joint axle assembly and other connection components, we're going to make sure that that is easily serviceable. And for our requirements, we need to make sure that our front drive system is able to adapt to both the custom differential or the Hilliard differential. And we'll go over a little bit more about this later. And also that the footbox area should be able to accommodate for the 95th percentile of males and then also the 5th percentile of females. And we're going to have two CVT tuning combinations that's going to be able to be specified for specific events. For acceleration and speed, and another one for torque and power. And for our specifications, we need to make sure that we have a fully functional four-wheel drive system that should be able to continuously drive for 2 hours. And this is around 22 of the 38.5 miles that we have required, and this is excluding refueling. And also that the front wheels should be able to withstand 265 foot-pounds before the wheel slip, and that the overall weight should not exceed 182.7 pounds, including the engine. And this metric was determined by just our previous weight requirement. And our main goal is to just either maintain that or go a little below that. And for the CVT system, it should be able to provide 100-foot acceleration within 4.3 seconds on pavement. And the rear drive system, which includes the reduction box, the transfer case, and all of its respective components, should have a minimum factor of safety of 2 due to complex serviceability.
Moving on to a few of the things that we've noticed over the past two competitions. Some of these points we got from the design judge feedback in Arizona and especially in South Carolina. We got a lot of good feedback after the design presentations. The first one is that we need to do more in-car testing to validate our simulation conditions. Especially they highlighted with our gears and with our half shafts. Another thing was to do an engine dyno to get more accurate power curves, which is really important for our torque related calculations. We also need to examine our gears and determine their predicted life. And then also look at them under a microscope to see how they wear out and fatigue with testing and also during endurance races or after endurance races in competition. For our front drive system, we have noticed that with the Hilliard, our position of the differential, and the space that we have to work with in the footbox is extremely limited and restricting other subsystems and what we can do with it. Um, and then also our inboard and outboard spines are not the same shape. So we're looking into a way to make it so that it's consistent, which means looking into custom solutions. Um, as for our guarding, it's currently not very serviceable. One of the things that we'll talk about later, Lucas will talk about the CVT guarding. This is a project that we're going to be working on. And then also we've had some consistent issues with the CVT prior to the Arizona competition and prior to the Carolina competition. We've tried to do design of experiments multiple times and even shortened full factorial in parentheses testing. But we've always run into issues with various issues where we could not even get one combination to work. So eventually we were able to get a combination before each competition. So we're going to be working on that. This is something that Lucas is working on right now, improving our testing so that we can eventually meet our requirement of having two CVT combinations for competition. Also, we've seen some inconsistency at home and at comp with our performance. So we can try to figure that out by testing on dirt and pavement, which we have done a little bit, but we need to redesign our experiments with that too. And the last thing is with our gear case, we've noticed before Arizona and this fall as well, the input shaft to the gear case has been wobbly. And a few weeks ago, right before Thanksgiving, this happened again where we noticed it was getting really wobbly and it got to the point where it completely sheared all the teeth off of, I think it was two gears in the gear case or something like that. But we'll talk about that a little bit later.
Yeah, and just for the overall plan, just to summarize what Ella said, we're going to be mainly focusing on making some changes within the front drive system. So this is going to include a custom inboard differential, and then also it's going to be able to impact the U-joint axles. And with this change, the gear ratios are going to be changing because the Hilliard had a set ratio, and with the custom front drive system, we're able to customize our own gear ratios, and through that, we're going to be changing the ratio for the bevel box. So we're currently in the process of manufacturing the housing for this. And for the guarding, we need to be able to fix all the guarding for the prop shaft in the CVT case just to make it more serviceable. Because at competition, we were having some issues with just taking it apart, and then also with the tech inspection overall. And for the CVT, we're looking to get more data overall, which includes like shift curves and repairing and servicing this with different other components like the ramps. And for the gear case, we're going to be focusing on trying to, I guess, better improve the issues that we were having with the input shaft. So this could include like increasing the space between the bearings or changing how we're actually inserting the input shaft into the gear case itself. And another thing to note is that for the upcoming year, four-wheel drive is no longer required, but for our team, we think it's best to still follow through by committing to a four-wheel drive system.
Okay, so first we're going to talk about the front drive system. In the September PDR, we came up with the problem statement that the Hilliard differential fulfills the current performance requirements and specifications. However, it restricts the optimization of the front drive system design. We have updated this problem statement to the Hilliard meets performance requirements and specifications, but does not allow for customization and restricts in-house parts manufacturing. Its preset dimensions and gear ratios restrict gear train ratios, interface with power distribution, and dimensions and/or positions of other components in the footbox, including the shape of the footbox itself. So this is just a really brief overview of the Hilliard. I don't know how much you guys have looked into it before, but it is an electromagnetically activated bidirectional overrunning clutch, which just means it works. It's a differential. It works. The two wheels can spin at different speeds. It's magnetically activated by this magnetic plate that you can turn on and off to grip onto the big gear. You can see it right here. And it basically will work similarly to the custom differential design that we have, but it won't require, or custom differential will not require that electromagnetic part. Um, and its weight is about 21.1 pounds. So our two custom options that we discussed in September were the custom differential, like inboard custom differential with a bevel gear reduction of 3 and using the one-way bearing model of the FRN 473Z, a press fit of 21.65 microns. If you want, you can go back and look at these slides from the last PDR if you want more details on that, or you can ask questions later. The hubs design, uh, we compared the hubs design in that PDR using the 442Z model, which is just like a smaller one-way bearing. It had a different press fit value, but I'll talk about this later. I'm looking into other one-way bearing models as well. So, and also these calculations are based on coefficients of friction that we used for the custom differential. However, we've been doing some research and we might have to change our numbers. So I'll talk about that later. The hubs design would have a simple transfer case and instead of having like a whole inboard differential, so it'd be a lot smaller. And it wouldn't be compatible with the current system, including the Hilliard. So this would require more factors to change. The similarities between these two systems is that the custom, they both have custom inboard spline shapes, so it can reduce our cost for hobbing with Gleason. And then they also both use the Sprag Clutcher one-way bearing approach. So to go over why we decided to go with the custom inboard differential, we wanted to meet the adaptability of requirement of being able to go back to the Hilliard system during testing because we don't know, going to the reliability bullet point, we don't know how reliable the Sprag clutch system is. So for both the hubs and the custom differential, we need to be able to just do testing. And the custom differential, inboard custom differential is more developed and also more similar to the Hilliard than the hub's front drive system design. So that's why the custom differential would be more reliable in our eyes at this point in time. As for performance, we still need to measure and quantify both of these, but we think that the custom diff will function similarly to the Hilliard. And then as for manufacturing, we have discussed with both Professor Mira and Bill, and we should be able to press fit the bearings in-house. They're both going to be challenging, but the thing with the hubs is that we would have to make spares, which would require more press fits than doing an inboard differential. If you want to look into more of like why we decided on this, I have a link to the document there that has a more detailed thought process. So to go over the custom differential design, it has a reduction of 3. The big ring, or the big bevel gear, which is depicted right here, has an outer diameter of 5.5685. That should give you an idea of the size. Overall, the weight should be around 15 pounds, so it will be a weight reduction compared to the Hilliard. It'll allow for a custom spline shape and variability with gear ratios in the future. Currently, it is exchangeable with the Hilliard due to its gear ratios, and the feet are at the same height as the Hilliard. We can make small adjustment to these in the future. And then there are a few manufacturing difficulties that we will face with this, with the bearing press fit. It is possible according to Bill, but we're still working through that process. So if you have questions, we can talk about that later. And then also with the bevel gear and the pinion gear, Gleason has asked for more blanks, so we're currently in the process of getting more blanks to them. I think they need like 3.
Yeah, 3 extra sets.
Yeah, 3 extra sets of each. So that does not help us with cost efficiency, but that's okay. So that's what we're working on right now. Here is the CAD. You've seen this before. The right in here is the one-way bearings. This is the 473Z from GMN, which we would get a sponsorship but we already have these bearings, but if we wanted to buy more, we can get a sponsorship with them. And then this is the SKF 22207E. It's a dual tapered roller bearing. And then these two axles are separated so the axles can move separately, uh, allowing it to be a differential, of course. And then here's some more information on the press fit calculations. We have a MATLAB code to run these calculations. The problem that we're facing right now is that our coefficients of friction are not reliable numbers. Um, I did some research and initially we were using for our friction coefficient um, 0.3, but looking into other sources, I found zero point 0.8 as an option, which would reduce our press fit uh, interference significantly. So we're still working on this. If you know any like really good resources that from the top of your head, that would be really great, but we're still doing research on this. Last thing, Ben, if you went to the frame and chassis PDR, you might have heard Benzier talk about the footbox meeting that we had. So you can go back and watch that video if you want more information on this. But the concerns we brought up in the meeting is that we wanted to have the option to go back to the Hilliard during testing and having a tapered footbox. You can see that here on the right, tapered up by 8.7 degrees. Currently, it is level with the rest of the cockpit. We did a lot of math and it would be really it would not be possible to go back to the Hilliard during testing if we were to adjust it and make the custom differential also work. And also it would be like we would have to do a lot of redesigning with our current design for the differential. So it would not be a feasible process at this point in time. And we voted against tapering the footbox. So we're keeping the footbox as is right now. The issue that we see from this is that Drivetrain greatly restricts other subsystems in the footbox, and we don't want that to be the case in the future. So by transitioning towards a custom differential, developing and testing it, and having a design that we know works, in the future we can customize it so that we can reduce these restrictions with other subsystems.
And for the gear case, we were having a lot of issues with the input shaft being wobbly. And as you can see in the picture recently, the input shaft kind of destroyed our entire gear case. So some considerations that we were thinking about of possibly fixing this is by changing the input shaft to a press fit, or also maybe increasing the width of the bearings that's actually holding the input shaft. And we did some hand calculations here, where we accounted for the bearing loads and then also the belt tensioning from the CVT. And from this, we made a MATLAB code to test like varying widths for the bearing spacing. And from this, we can tell how much the loads are being decreased, but we don't really have a solid idea of how we can determine what is the proper distance to like increase the width by. So if you guys have any suggestions on like identifying that, that would be greatly helpful. Uh, oh yeah, and then for this picture right here for the input shaft, we observed some issues here in the red circle. As you can see, if you look closely enough, the input shaft is a little worn down, and we observed this. And we believe that this is from the bearing wearing down the actual shaft. And if you do some measurements, this part, the diameter is a little less than the rest of the actual shaft. So this was also accounting for the looseness of the actual input shaft. And yeah, so the plans before, so we were actually thinking about this right before the whole gear case actually blew up. We were thinking about measuring the radial displacement of the shaft under different kind of loads, and we were thinking about doing some testing inside the actual car. But since the gear case is completely destroyed now, we don't really have a way to do that. So we have a new plan, which is making a whole new gear case, which was our original plan too, but also to make gears so we actually have a full complete gear case. Currently, we have the gear blanks for gear 2 and 3. And we recently got a new input and output shaft from Gleason, but the problem is that the dimensions were similar to the ones that we had before. So we think that they're still going to be wobbling. So we're going to have to make some additional changes to the input shaft. And yeah, some other things that we need to think about is possibly having a light press fit into the actual bearing for the input shaft to possibly solve this. So we really want to know if there's kind of a way to measure the wobble now that the gears are completely destroyed, or if you guys have any suggestions for how we could approach this problem in the future. And some simulations and analysis that we've done this year is at previous competitions, we had issues where the axle links were incorrect, so they would actually fall out of the car. So this year, we've been really focusing on making sure that this doesn't happen. So we developed 3 different kind of motion simulations. On the left, you can see there's a simple simulation with just the yokes of the actual U joints, just to make sure that there's no binding within the actual um, yokes themselves. And in the middle, and then on the far right, you can see the front and the rear system, which includes all the components that the actual axles interface with. So for example, the front, there's the steering rack, the suspension, the hubs, and everything else that uh, basically interacts with the axles. So this accounts for maximum steering angle, full suspension travel, and then yeah, that's basically it. And some simulation and additional analysis that we're looking to do for the future is for the custom differential, we're looking to do additional bearing press fit calculations just to verify because we're having some discrepancies in what we're finding. And for the U joints, we're looking to do additional FEA to verify the new yoke geometry, which Bryce will go over because we're trying to make some additional adjustments just so we can accommodate for a larger range of motion for the steering system. And we're hoping that the structural integrity of the actual yokes is not being limited after we make these changes. And for gears, which includes anything like the custom differential, the gear case, or the bubble box, this year we kind of discovered a new tool, which is Kissoff. So we're in the process of kind of learning how to use that to our advantage and to verify all the like the calculations that we previously had. And yeah. And some additional testing that we're looking to do for this season is after we went to competition, we got a lot of feedback from the judges, and uh, a lot of this is coming from the judges, and these are the improvements that we're looking to have. For the gears, we're looking to kind of have a better understanding of the overall life, so we need to develop a end of life prediction. We need to also test for fatigue and under like different kind of conditions because at competition or when the car is driving, there's going to be varying loads and torque values that it's going to be using. So we're looking to kind of find a way to uh, find what those values are and the ranges for that, and then also testing it. And for the gears themselves, we want to inspect them over different kind of periods of time. So like if we run them for, let's say, like 4 hours of uh, a mock endurance race, we want to see how much the gears are actually being impacted. So we can observe this through microscopes by looking at the cracks or pits. And for the universal joints, we want to look to see if there's any ear interference to avoid any issues like the past, and also some CVT changes, which Lucas will further explain later. And after our design and manufacturing, we're looking to fully make a full assembly of the universal joints. And then also we're looking to find a way to use an engine dyno because the judges told us that although we have like data for like how much power or how much torque the engine has, we want to be able to verify those numbers. So this can also impact a lot of all of our other design choices that we have, or just to verify it in general. And for the gears, we wanted to find a way to measure how it kind of functions in a long in an endurance race by, like I mentioned earlier, measuring RPM and torque values over a set amount of period.
This slide is kind of just summarizing a few things that we brought up earlier. For research and development with regards to manufacturing, we're looking into the coefficients of friction that are used for calculating our press fit, because we don't think it's very accurate at this point in time. For design, we're also looking into, for the gear case input shaft, quantifying what we're calling the wobble. And then as for the hubs, I have a little overview of what I'm working on right now. In September, I talked about the design in the top right. This used two FRN 442Z one-way bearings or sprag clutches. And basically, we would use two, and the 90% of the sum of the nominal torques of each bearing would give us the total nominal torque. So that was the thought process behind having two sprag clutches. Some current research and development that I'm doing is looking into, is there a way to have all the bearings have the same bore diameter, and is that beneficial to the design? Um, Looking into using tapered roller bearings in maybe the hubs, but mostly the upright. I'm just basing it off of our current upright design. I know that in the suspension PDR, if you were there, Miles talked about his new design that he's working on, but this is just based on our current one in the car. Um, Also looking into using one sprag clutch instead of two, so maybe looking at larger sprag clutches. As for the shaft, using a spline or keyed shaft with um, and checking the press fit interferences. And then also, again, same thing with the custom differential. Our coefficients of friction are not reliable. So these are all things that I'm currently working on. We had to do a lot of preparation for the Carolina competition, so the hubs design has not developed in a certain direction that much, but this is a project that I'm going to continue to work on throughout the year. So you will see more you will see more updates throughout the year about this. And then this is just a real quick overview of the different bearings I've looked at. The 442s is in this slide in the top right. And those are the press fit calculations. The custom differential uses the 473, which is just a larger one. And then I was looking into a different size, the 463s, which are a little bit smaller than the 473s. And I used it in this diagram right here because I was looking into designs that I could just use one sprag clutch instead for cost reduction, and also simply because it requires a pretty strong press fit, and reducing that to one instead of two press fits would be probably ideal. Would you like to sit down?
Yeah. Hi, I'm Lucas. You're going to hear my voice hopefully through Ella's computer, but you will see me from my camera. I'm Lucas. I already said my name. I'm the Continuously Variable Transmission Project Team Lead, or CVT. Next slide, please. So I'm just going to go over some background and observations we've had just on the CVT. As mentioned, we have no good data to confirm that we have the optimal tuning. We have the basic 100-foot acceleration run. However, that to find better options, it's just a guess and check of switch to a different tuning and then do it again and again and again. We don't have a sort of look at the data from it and then figure out what we need. Another issue is that the case wobbles and breaks a lot. So as it wobbles, big gaps form. And also you can see in the top right photo, one of the tabs broke during competition. We'd like to avoid that in the future. Dirt also enters the system a lot. For a part of the car that mostly relies on most of it running off of relatively little friction, that becomes an issue. Belts melt when idling for a long time. That would also like to be fixed. We can't use our heaviest springs. Our flyweights aren't able to overcome them and fully engage this primary. A couple of components of our CVT are in stages of deterioration. Last PDR, I talked about the belts specifically. Those have been fixed. We've bought new ones. The main one that's being targeted is, you can see on the lower right, the secondary ramps or the helical cam. It's kind of hard to see in the photo, but the silver area, there's a very nice curve worn into it where it should be straight. So what are we going to do about this? To increase the structural strength of the CVT, we plan to thicken the backplate. If you look at the bottom two pictures, you'll see our 2025 year, which is there's the very thin plate running along right there. It measures about 1/20th of an inch. There's the 2019 year car with Tennessee all the way on the right, which has a plate of about 1/8 of an inch. We probably don't plan to go all the way back up to Tennessee's size. However, we'd like to get a little bit thicker to hopefully reduce that wobble. Another issue to fix, another way to fix this that we're going to try is attaching another tab to the frame. For the CVT to connect to. Currently, the backplate is only attached up by the engine and the entire bottom has nowhere to attach to, so it just wobbles around. I'm going to say the word wobble apparently a lot. The other issue we'd like to fix is decrease the amount of dirt that's going in. Currently, the case has this large grate on the front of it, which works very well. It's just a passive cooling system. Air comes in and out and cools the primary down and the secondary. But because it's so close to the ground, a lot of dirt gets kicked up and goes into it. We're thinking about creating a swappable front plate right there that'll have a tube that will run off it and go higher up on the car so we can avoid sucking in dirt, is the idea. The problem, of course, with that is we may not get as much air flowing through, so we'll have to run some tests to make sure we're still cooling correctly. And for the deterioration of certain components and using heavier springs, we're going to manufacture some flyweights of denser materials. We can't just make larger flyweights or stick on the smaller ones we have because currently we're at as large. It just doesn't fit in the barrel anymore if we try to put more weight. So we'll make it out of a denser material. We're also going to look to see if we can manufacture the worn components, and if not, we'll just have to buy more from Gauged. So testing. The big one is getting curve shift data. We've worked with DataAC a lot, and they've done an amazing job so far. The first idea we worked with was laser tachometers, which got us that top graph you can see right there. So it showed that it worked. The only problem is that it could only run on jacks, so the CVT didn't get any torque feedback from the road. So it's definitely not an ideal curve shift, but we don't know whether that's because we have a bad tuning or because we're running on top of jacks. So we're currently going back to Hall effect sensors again to see if we can come up with a system that works. And so far, you can see one test in which we attached the primary to the lathe and stuck a Hall effect sensor next to it. Seems to be working pretty well. Hopefully that will come out and we'll get good curve shift data. And that will make we're able to then prove that we have the best tuning that we can have, and will also help us work towards the adaptability component, which the only components we're allowed to switch out at a competition is the preload on the secondary and the belt tension. These tests will have to occur outdoors when it's a little bit warmer. The other test we need to do is making a prototype of the sealed sort of no-grate CVT case and stick a temperature probe inside to collect temperature data. We did some initial temperature data. We have some initial temperature data from a while ago, and we did a little bit November 23rd, which was a week or so ago, a little more. And that went very well, but we'll need to make a prototype to make sure that we're not cooking the belts. Yeah. And that's my portion.
I'm going to take this.
It's long. As it full.
Hello, I'm Bryce Sabin. I'm the power distribution PTL for this semester. So for the background for our the half shafts and the yoke connections, right now we have a very limited like range of motion. We're currently at around 32 degrees but we want to get to 45, which equates to 1.8 inches steering rack movement. And so we're limited by our steering and our handling performance, so we want to improve that upcoming design. And then the current design is also difficult. There's just the flange that you can see in the CAD model. It's very difficult to manufacture consistently and accurately. And so we want to try and remove this or make it easier to manufacture, just to improve our serviceability for this design. And then also so the current design is it's a steel flange that's bolted to the yoke, that's made of aluminum, so that way we can weld the whole assembly together. And so the changes I would like to make for increasing the range of motion, I mostly just increase the chamfer size on the yokes. This allows for the full 45 degrees range of motion, but it lowers our factor of safety to around 1.25. So I want to confirm our FEA with physical testing soon. And then for the easier like welding and manufacturing, at least for the outboard yokes, I want to change them to 1018 steel, so that way we can weld directly to the spline connection. And simplifies manufacturing, and it's a lot easier to make it. We don't require as much complex machinery and fixturing. And then just further testing that I'm in the process is the physical range of motion test to ensure that the the model on NX matches the physical model of the yoke, and then confirm that it does meet the mobility requirement of the full 1.8 inches of rack movement. And then also I want to double check the testing with our torque testing rig to ensure that it doesn't fail, considering we do have a lower factor of safety. And then also with that lower factor of safety, I want to try and perform a fatigue analysis. So an endurance race would run about 30,000 cycles. So I want to take the kind of the average load that's going to be on the yoke and ensure that it doesn't fail after the full race.
Yeah, and finally, we have some of our questions that we kind of set. Not really sure if any of you guys read it or not, but we'll just repeat it just in case. One of our most I guess pressing questions is how are we able to test the full life of a gear? Like, is there any way to verify this without running like an actual physical gear until it breaks? Because the judges at competition told us that apparently some teams literally just make a gear and then run it until it breaks. But I don't think our team has that kind of capability. So if you guys have any suggestions for that, that would be great. Also, is there any way to measure or identify the variations of loads or duty cycles? So this is like I mentioned earlier, the gears are going to be undergoing different kind of torque and RPM values, but certain ranges are going to be run for a longer period compared to others. So if we're able to identify this, we're able to make more accurate fatigue analysis or yeah, more accurate fatigue analysis. And also from the CVT side, we were wondering if any of you guys had any suggestions on better ways to collect the shift curve data. And finally, for the gear case, we're having a lot of issues with the input shaft. So if you guys have any suggestions for how we can actually measure the wobble or maybe verify or kind of find a good reason of or a good stopping point of where we want to increase the width for the actual bearings. And yeah.
Does anyone have any questions for us or feedback?
Good job, guys. A couple things. I guess starting all the way back to the beginning, if you go to like the Rex and specs, I had one question. I think it was on like the second Rex and specs slide. There's some of the factor of safety that I was curious about.
Oh, for the rear drive system?
Maybe. Yeah. Can you just explain like why you're saying that complex serviceability means you need a factor of safety of two? Because like in my mind, the serviceability isn't like I don't know that I don't see why that should inform like your load cases.
Oh, it's just because a lot of the things that are involved in the rear drive system, like the list that we have, if we experience any kind of mechanical failure during competition, it would take a really long time to like fix or do anything at competition. So with this, we want to ensure that we have a relatively high factor of safety to make sure to avoid any of these like costly like
Gotcha.
serviceability issues.
Okay, yeah, that makes sense.
Yeah.
Yeah,
Um,
just to classify parts of our subsystem.
Which is why, like, for example, like the U joints, the factor of safety is significantly lower because if we do have to like repair or find a spare, it's going to be a lot faster than, for example, taking out the whole reduction box or gear case.
yeah, no, that makes a lot of sense. I misunderstood what you guys meant before, so that
Mhm.
sounds good.
I've got a comment about the. I had a note about it. There was at one point where it was talked about that bringing up a tube to the top of the or like higher up in the car to allow for air to come through the top versus the bottom to avoid dirt getting into the CVT. Um, One comment I've got about that is on one of the older cars, there was an attempt to do that. But one of the concerns with it was at competition, especially in the spring, um, a lot of the areas we go to get really muddy. And so all it takes is like one glop of dirt essentially to hit the top, and that entire tube is blocked. So I've got nothing against it, but that's I would just consider that.
Uh, that's a very fair concern. I'm not particularly uh wedded to this concept. I just want to try it out since we went to South Carolina. I noticed a lot of the teams were now doing something very similar, and I, for my somewhat selfishness, was getting tired of cleaning the CVT. So I wanted to see if this was a possibility of, it has its purpose as well. I'm making a joke of my own laziness, but you know, I wanted to see if that was something we could do without cooking belts and, as you brought up, without creating another problem of air intake.
Oh no, I completely agree. Chaz is on this line, and he was one of those. He was among the person who took that CVT and threw it in a bunch of ice water. So I completely get it. It's just more of a heads up of like you'll probably run into that issue too.
Okay, thank you. I hadn't considered it yet.
Yeah, I forget if that you're able to. I guess there was nothing in the rules where you could throw it in the ice, so that was that was fun. Um, Great job, guys. I had a quick question. Well, one thing I'll applaud is the CVT slides. This is new thing, and I think this is good to look at the CVT guarding. It's always an afterthought, and then and as you guys have known, it's been an issue for multiple years now. So definitely good to plan ahead. I would really try and think of if you can build more space around the guard to the CVT. That's always been an issue with the guard. Yet you have to account for it to be able to shift, or depending on how you design it, if you do the pin and slot, maybe you can keep it. Um, but yeah, just try and give yourself some space there between there and the bottom of the frame if you can, since it's always been an issue. One thing quick to put on this slide, I just wanted to make sure you knew that that thin steel CVT back plate is steel in 2025, and in 2019 that's aluminum. So that's why I think it was a lot thicker. So obviously, based on what materials you choose, you can decide on the thickness. Can we go back to gear case slide. Let's see. Yeah, that looks good. Okay. So I think you guys are thinking about the right thing. I want to be careful what I say here because obviously this design here was kind of it's not the prettiest thing. It was kind of just to get us moving. So I think it's definitely, good to look at some updates and some changes. But definitely just want to watch avoiding reinventing the wheel a little bit with the input shaft. That whole system, I use the same as Daniel's design and all the drivetrains before then. And this wobbly thing going on. I just want to make sure it's not I think this failure is kind of coming from how loose the input shaft is from being worn down, like you guys were mentioning. Um, and then also the tension on the CVT belt. Daniel's years, Augie years, and the beginning of my years, we ran a clutch bracket, obviously, to help with this as well. And then the first year of Genesee, I think me and Bruno, we made the engine mount, stiff enough that it didn't need a clutch bracket. And we liked that you weren't fighting the center to center distance between the engine and the gear case and the clutch bracket. But I think putting beefier bearings in there definitely doesn't hurt if you guys have to redo the gear case anyway. If that helps add more reliability to the system, I don't think it hurts. I just know we ran that for a lot of years. So just don't want to go too much down the rabbit hole. Besides looking at I know the CVT belt has been super tight in recent years to kind of gain some more of that efficiency, but it's also burning up those belts. So yeah, just wanted to look at that. And then you guys aren't planning to, you mentioned changing the bearings in the middle or on the outside to metric. For this spring, are you guys planning to run like the same gear ratios or anything, or what else is changing?
Yeah, so we were planning to run the same gear ratios, definitely in the gear case. Since we're we're transitioning to the custom differential, we're also making a new bevel box, which will have a 1-to-1 ratio instead of I forget what the current ratio is. Top of my head.
It's like 2 to 3.
Yeah. So that will change, but the gears in the gear case themselves will not change. We just want to keep that consistent for now. We're maintaining a system that can be switched around with the Hilliard system.
Got it. Yeah, no, I think you guys are going about it right, and I'm not saying that just because I'm biased to my to my gear train. It's just that it's December, and I know to get any of those new spur gears. I know you're working with Gleason right now on a few other gears, but if you added spur gears on top of that, it would be really tight to get it in time. So I just wanted to make sure that was
Yeah.
you guys are growing on that track, so that's sweet.
Mhm. Yeah, so one of the things that we wanted to point out here was the wear that we see from the bearings. I know, Chaz, you suggested beefier bearings. So we're working on all those calculations as you see here. We just boiled it down to a very simple statics problem in this slide.
Yep.
But do you have any suggestions? We were thinking about press fitting the two bearings, like a light press fit on the shaft, but I'm still concerned with the wear that we might see. I don't know how much if
Yeah, is
if
that wear from the bearing? Is that wear from the bearing or is it from the gear case? Because I
uh
can't tell on this angle if it could just be pulling up against the aluminum gear case. Or I
we
guess that would really just wear away the aluminum.
we were thinking it was from the bearing itself, but it's really hard to tell in this photo, so we'll have to
Just
check.
by measuring from that spur
Yeah.
gear,
Yeah.
measure with some calipers,
Mm.
should be able to tell.
Yeah, we'll double
Uh,
check that.
I'm sorry, I kind of cut you off midway.
It's okay.
What was the question again with that?
So just if you guys had any suggestions off the top of your head, regarding we have the bearing bore diameter is supposedly the same as our shaft diameter right here. But we noticed that just in this section, it wore down a little bit. And also, we took some measurements of this shaft as well as a new shaft that we just got back from Gleason. We sent them the same drawing because we figured this might happen again after it happened before Arizona, and that just happened 2 weeks ago. Um, and we noticed that the diameter here, not in the worn out part, is the correct diameter. So it's the exact same diameter as our bearing bore diameter. But on the new shaft we just received, I guess the tolerances were too large and the shaft is like you can't visibly see it, but it measured smaller, like than the diameter that we asked for. So one thing that we need to work on is making sure our tolerances that we give Gleason are better, essentially. We need better drawings.
Yeah, I'd have to see yeah, the drawing. Do you know the tolerance gap that you have for that
Well,
diameter there?
the thing is, on the drawing, there is no tolerance. It's
Oh,
just a raw
brother.
diameter. So we were just looking at this right before this presentation. So we think maybe that's um an issue that we're like maybe it's just like a communication issue with Gleason. So since we don't
Say drawing chest,
really, I didn't.
there's a general tolerance of that one.
Oh,
General.
well, yeah, there's a general tolerance, but there's not like a.
It's the same as what he said.
Oh, okay. Well,
But
Clark
did you
said
guys
that.
do the you gave them the blanks though, right?
Yeah.
Yeah, but yeah, on the drawing there is like a general tolerance, but um,
They don't touch that section though, right? Like they only touch the section that's splined.
So I don't remember, did we?
I want to say
Oh,
like, because I think this is maybe the shaft that I originally did. Like we used to, I think, check the bearings like when we were manufacturing the blanks. So like Chaz
Yeah.
is saying, like since Gleason doesn't touch that,
yeah.
and we would have already purchased the bearings, like we could ensure that that fit was exactly how we needed before we sent it to Gleason. So
mhm.
that's
Okay.
something that I'd recommend doing for the future.
Okay.
What would you say, like, do you have any feedback regarding press fitting with this shaft? Because we're thinking a light press fit, just to help reduce the wobble. Um, like, do you have any feedback on if that's like a terrible idea or not?
You could do a press fit.
Okay.
I think you gotta make sure it's obviously the right interference.
Mhm.
Feel free to jump in, Daniel, or anyone, but I think that would be fine. Obviously, taking apart the gear case be a lot more difficult. I don't know if it's
Not sure if it would weigh aluminum a bit more on the gear case itself. If
Can you repeat
press
that?
fit it.
Really?
Sorry. I'm saying that it might wear the aluminum in the gear case a
Mhm.
bit more. I'm just like thinking intuitively because we're press fitting it to a steel shaft and you have aluminum on the other side.
Mhm.
If you have the same wobble, then the wobble would probably go into the aluminum gear case,
Yeah.
Okay.
maybe.
I see what you mean. Okay.
But I guess
That's
one question about that. So, did you guys consider using the bracket between the input shaft and the primary,
Sorry,
like
did
the
you
clutch
ask?
bracket, like the clutch bracket that we used to have? We used to use it to kind of stiffen this connection to avoid this wobble.
Yeah.
Did you look
Yeah.
into doing that?
We've did we try it on this car? Yeah, we did.
We did before.
We used it on this car, but I think we stopped using it when we started increasing the center to center distance by a lot, which we went back on that. I don't know why we were doing that. I don't know what happened. We were having issues with the CVT and a lot of things got messed up. And so we tried that, but then our center distance was too great. Like we were going towards 10 inches, I think, which is too much. I don't know how we achieved that. Um, but then we went back to the standard around 8.5. Is that right?
Yeah, that's it.
Like around 8.5. So we could try that again. That would definitely help. Yeah, we
Yeah, I
haven't.
remember that we used to use that on a lot of cars, and that really helped us. It was kind of a pain to install, but it did
Yeah,
help prevent this wobble. So
yeah. Even make a new one.
Yeah, I'd strongly recommend if you do the clutch bracket. Like when I originally designed that, I had a cam mechanism. It seizes up really badly, at least the version that I had designed. And so I'd strongly recommend like making a cam or something to change the center to center because doing it by hand was really bad.
Okay.
That cam went missing a while ago.
It was a piece of metal on a bolt, so it's pretty easy to
Yeah.
make a new one.
yeah, nice presentation for the team. I'm really happy as well that the guarding is having like making an appearance early on for the first time. I had one question about four-wheel drive. You may have discussed this on one of the earlier PDRs. I unfortunately missed the last two. But is the PDR really no longer required? Or sorry, the four-wheel drive no longer required?
Yeah,
And
that
if
is correct.
so, why did you choose not to run with it or to run with it?
So, we're continuing with the four-wheel drive because we really want to test out this custom differential setup.
Yeah.
And another thing is they say it's no longer required, but they heavily suggest using four-wheel drive, which we think means that there might be a lot of obstacles that they don't require four-wheel drive, but will be very difficult to get over without it. Um, is for S&T, which we
Okay.
want to improve our performance in, and definitely endurance.
Mhm.
Probably for design points,
Yeah.
they'll give more points, right?
Yeah.
Yeah.
Interesting.
So it's the trade-off of like, do you want to be light and fast, or do you want to like be actually able to complete the endurance race? And our car is capable, like we're relatively quick compared to a fair amount of teams. So I think that we can continue to work with our four-wheel drive setup and improve it, especially with going custom. And we think we can go far with this, regardless of other teams might having the advantage of two-wheel drive, but we see greater advantages with four-wheel drive.
I guess if Augie's done, I had another question. You mentioned like gear life and gear testing a couple times, and it
Yeah.
looked like you already have a rig that can like more or less run the gear train on a bench top. Have you considered just doing like a long-term benchtop test of the gear train? Like maybe you can find just like an electric motor that can provide, essentially the same input to either like the actual shaft or like a simpler shaft that you can just, I don't know, attach to like gear two.
We could modify this, but this testing rig is mostly for testing the flanges, so I don't know. We might be able to modify it in a way that it's like changeable. But this testing rig is mostly for like keeping this stationary.
I
So
mean, could
we'll
you
have to
build
work
like
on
a different rig? Like
it.
if you have spare gears, right? That might be like an easier way to do long-term life testing, like fully decoupled from the vehicle if you have a separate set of gears.
Yeah, I don't know if we have a full set of gears right now. Especially since we just destroyed our last gear case. So we're gonna work on that and we'll scavenge through the cabinet to see if we have any like old gears that we could potentially use, but this might be our only set. So but that is a good idea.
Yeah, and then also like there is kind of like an issue if we do use like older gears because they might already have like um wear in them. So if we do try to collect data for it, it might lead to some kind of like I guess like re- uh inaccurate data or like correlation when we're trying to like validate certain things.
Yeah, I mean, that all makes sense. Maybe, it's something that you could try to set up and put in place for like next year. So if you're gonna get a new set of gears next year, and this is something that you know the judges want you to do,
Mhm.
you can like plan ahead, try to get a second set of blanks. I don't know if you're planning to change like the gear blanks from next year. If not, like that should be pretty easy to do.
Mhm.
Okay, I see. Thank you.
I'm surprised the judges kind of went that route with this because the gears are, the design behind them is very, kind of traditional. At least the tooth wise, I could see them going into the webbing pattern as kind of a whole separate side of this. That's why we try and do the FEA ahead of time. But I know our gears are relatively thin compared to other teams, which helps keep them competitive. Yeah, going back to what we said with the input shaft, I think if you have a lot of concerns with the wobbliness, at least my thoughts would be not doing the maybe not doing the press fit, but doing those larger bearings. And then if you are able to spread it out somehow, if you're able to get that distance between the bearings a little further, like you kind of have set up here, could be beneficial. I just know we've run that rig for a long time.
Mhm.
But there just might be new load cases now if the center to center on the CVT is off. Are you guys changing that with the engine mounting, or how are you adjusting it now?
The current engine mount is the same as Genesee, and we're
Okay.
keeping that for now.
Okay.
We're trying to maintain a lot of the rear drive system, like keeping that consistent with how the car was in 2025, or in Arizona. It is 2025. Um, so that we can focus on making our changes in the front drive system and not have to deal with a bunch of factors changing.
Do you have, oh, sorry, Chaz, did you have another thing?
No, feel free to.
Okay. Do you guys know like what's causing the wobble?
So it has to do with like this wearing out probably. Because when we initially put it in, it's okay. I think we put shims in one time. We did,
Add one more thing, I don't know if they get here there, but.
probably not.
Yeah, so.
Do you want to unmute? Do you want?
Yeah.
I can mute.
It's fine.
Okay. Okay.
Hey guys, so one thing is that input shaft. So last year we had the same failure, and the one in the picture is from many years ago. So we refitted that to fit into the current gear case, but I don't think it was made for that gear case. So it might have been that like something coming off of that process makes it wobbling too, because like you can see a third or second retaining ring groove on the right side. We put that in because it didn't fit into this gear case. I think this was made for like a way early on gear case, but we didn't have a spare when this broke last year. So like that might be part of the wobble or most of the causes of wobble too.
The one that we made for Arizona.
Yeah, so
That was
that's
Genesee's, right? Or did we make a new one for
the
that?
Genesee one broke before Arizona, and we
Yeah.
replaced it with this.
Yeah.
The ones you have is the blanks that we got Bill made last
Yeah.
year. So that should be fine, I hope. But you said it's not.
It's not
so
right.
I don't know.
Yeah. We'll have to look at
And
it.
you gave Bill the bearings. You were going to use fresh bearings.
Yeah, he had the bearings.
Okay. And you did and did you, I guess he set it up as a slip fit, or was anyone there with Bill I mean, I know he knows what he's doing. Um, they did a slip fit with those bearings.
Yeah, I mean, I'm not sure how the like process got wrong, but he had the bearings in the drawing the same one we sent to Gleason too. So not sure. Maybe there was a thing we did on the house to get the fillet in. So maybe during that Mira did some adjustments or something that might have been a thing too. But yeah, so I'm not really sure where it went wrong.
Yeah, I do know. There is sometimes some variation between bearings. Some pack you'll get from SKF. One will be a few thou under, the next one's a few thou over. And it is also weird because heat treat, in my experience, usually made them grow a hair in diameter. So might be able to try. I don't know if there's probably not a ton of options for the bearings if you can try and getting sets that are a few thousand or anything like that. Or just trying a few.
Mhm.
They obviously get expensive, but they're usually not exactly the same.
You. Okay, is there any other questions regarding gear case or anything else?
I've got a quick question, and this might sound real dumb for a second. But have you guys for the gear case and figuring out uh the distances at which the input shaft when it changes direction a little or not direction when it like loosens a little bit, at what point it then like breaks the rest of the gears? Have you guys just like put that into NX as like an assembly and just put a bunch of just gone nuts with the forces to see where it could break?
Like with the bearings in NX?
Yes.
No, we have not done that yet. We started looking, we didn't do a ton of work on this issue yet, because we started working on it like 2 weeks ago. And on that same day, the entire gear case exploded. So we haven't like really done a ton of work, and also we haven't even been able to measure the wobble in person. So, but that is definitely something that we can work on.
Yeah,
NX.
and all good. I saw that image too when it popped up in Discord. That brightened my day. Um, but I know it like for where I work, there is a lot of people will do like simulations as just like something to start with, and they'll just go crazy with it.
Yeah.
Um, but yeah, that's one option of something that can happen.
So you're saying like decreasing the diameter in X and then just applying a load and seeing how it reacts?
Yep,
Okay, nice.
it's very much a brute force method.
Mhm.
There's not, but at some point you'll probably start to see a pattern of like it starts to fail in one area versus another.
Okay. Yeah. We can add that to our simulations.
But yeah, I mean, other than that, fantastic presentation, guys. This is really cool.
Thanks. Any other questions?
Did
For the gears, so just
Oh,
to
you
add
go
on what, yeah, sorry, Chaz.
You're good.
Just to add to on what Chris kind of said, it's common to do something called SN testing, which is basically let's say you have your gear and you apply more load to it to kind of establish a lifetime for it. And then you apply a bit less load and then a bit less load and so on. Even though your application might be significantly less than what you're applying. And what the reason you're doing it is you're kind of trying to build a curve that has lifetime on one axis and what do you call it, the force, the stress on the other axis. And then you can kind of predict at like a lower load what your lifetime is going to be. Now that's, I understand you don't have the capability at all because it requires a lot of testing and a lot of gears, but maybe you could try something like an analysis, like a fatigue analysis on either a different size gear with the same load, or maybe the same gear but with a higher load and a lower load, and see if you get kind of like a curve there that you can at least use as a learning. Yeah,
That's a good idea. Thank you.
yeah, that's just something I thought of. And then maybe Gleason would have an idea about testing. I don't know if they do lifetime testing. I would assume they do because they make a lot of gears.
Yeah.
So yeah, maybe they can help you.
Yeah. We have a good contact at Gleason, so maybe we can get in touch with him again, hopefully.
Yeah, Chaz, you can go ahead. So I
two
got you.
more. I'll try and be quick. For another option for those other gears, if this is a problem that's really going downhill quick, you know what didn't end up happening, but what I initially wanted to do was, you had this webbed pattern, but then you also had a much more safer webbing pattern, so that something like that gear two probably couldn't even happen. You could have a full thickness blank. I don't think that's an option based on your time right now. But that's initially what I wanted, for if this situation arose, I had a much more conservative design, in case this happens like 2 weeks before you're going to competition or something. You might not have that time, but that's one option. Um, Second thing was for the yokes, you mentioned you're switching those to steel.
At least for now, the outboard yokes are going to be switched to steel, and then maybe we'll migrate to all of
Did
them.
you
But we also have
did
a
you
lot of
convince
spares.
Muir to make those, or did you convince Professor
Muir,
Muir to
Muir will
make?
make the 1018 on the yeah.
Really?
He'll make the 1018 yokes on. Yeah.
Wow, you guys really wore him down.
Why just the
Awesome.
outboard? Why not all of them?
He also offered to make a new gear case for us without us even like talking to him about it. Empty promises, but
I think he's been enjoying the Haas.
really? Okay. Apparently he's been enjoying the Haas
Yes,
recently. Okay.
Definitely any time between now and spring is, or before spring, yeah.
Yeah, if you have anything to give him to make, give it now.
Yeah.
Because I remember he emailed me once on January 1st. He was like, "Oh, I'm making something on the Haas. Can you help me clarify something?" I'm like, "Okay, sure."
We're gonna be
Why did you choose? Why did you choose to make only the outboard ones from 1018 and not the inboard ones too?
For now, we're just gonna do the outboard, simply because uh we can attach them directly to the splined like connection. And we also have a lot of spares of the current like design with the flange. So we're not gonna be able to move all of them to steel. And want to have an initial like baseline, I guess, for
Have most of those outer yokes were the ones that failed, right? Like, have the inner yokes been pretty good?
I'm sorry.
Like, and most of the failures have been the outboard yoke,
Yeah,
correct?
that's also true.
And they probably see different loading because you have the tire steering, if you're looking at the front. I think that makes sense to me as long as your inboards are doing fine.
Yeah.
I got one more
Yeah.
question about the custom differential
Yep.
and I guess the feet of the custom differential.
Yeah.
So it looks like kind of you're trying to replicate the Hilliard, but did you consider lowering these feet, basically mounting the differential lower so that you get some extra volume above in the foot box, and then you can also maybe lower just the shafts,
Yes, that is an option for
like the
us.
long shaft?
But we wanted to keep it at the Hilliard height for now so that we can make it exchangeable with the Hilliard while we do testing. Yeah, we did chop the feet of the Hilliard as well already. But once we're more confident in the performance of the custom differential, we have the option to lower it.
Okay, makes sense.
I forgot to ask during the frame PDR, but is there a plan for that front skid plate to be, even more beefier, or, it just seems like we buckle one of those tubes in the front every time. And especially if it's gonna remain flat, could be an issue.
Hi. Um,
No, I have extra thick, like the metal, adding an extra metal sheet to the skid plate itself. Honestly, now that I think about it, I don't know why we can't do that. We are able to do that, but no, I never thought of that, even though we did it. Yeah.
But there's no reason not to.
Mm-hmm.
I mean, some teams like weld their skate plate.
Yes, yes. Mhm.
Like I think Michigan does.
Yes.
Yeah.
Actually, one of them told me to do that. I was like, okay, okay. Um, for anyone who didn't hear, but after the first event of SNT, took it back to the paddock and we just added a second metal sheet over well underneath the skid plate, and I mean it didn't bend again. It clearly worked, so
that answer your question?
Yeah, yeah, no, it's always a balance because it obviously adds a lot of weight. Just seems every single time in SNT, so I wouldn't don't worry about the weight too much. Sweet.
I've got another question.
Cool.
So there, this is bouncing off of Daniel's idea of, or Daniel's thought of modifying the uh the rack, one of the racks that had a bunch of gears on it. It was one of the slides. I'm forgetting which one it was. Um, but in terms of like trying to run, trying to figure out the life cycle of a gear. I did a little bit of research as this presentation was happening, and a lot of it just came down to test it physically. Um, the size of the gears that you guys have are pretty large, so they're pretty expensive. Could you, or uh, have you guys thought of like going to McMaster, buying a gear that is kind of like yours but smaller, and then setting up a really small set, and then just running that? It would be a lot cheaper, and it wouldn't be exact. It's not going to give you the best information, but it'll give you something to work off of. Does that
We
make sense?
could look, yeah, definitely. We could look into that. The judges had also talked about like in-car gear testing, but the only thing that we could really like think about is just like running the car a bunch, like timing however long we're running it, and then inspecting the gears under a microscope. Is there like any other ideas you guys have regarding like testing the gears physically in the car? Because they were really emphasizing that for some reason.
Sled pull is pretty brutal. So in addition to, tying the car to a post,
Mhm.
adding a ton of weight on the rear and anything to
Yeah.
replicate sled pull. I know when I was doing it with the one, we were we were starting to get a little scared with the forces. So that could be good
Yeah.
to replicate. But I think the FEA, yeah, the FEA I did for these gears kind of replicate it where it's just obviously holding the wheel from slipping and then running the engine at max. But under that kind of that's just with static loading. So if you can get, fatigue loading in that kind of manner, that would kind of tie both things together with maybe what the judges are looking for. But you'd have to be ready to break something.
Yeah, the judges were they said that although we have static testing, they really want to see like other kind of or like other forms of testing like
Durability.
fatigue, like dynamic, or
Yep.
things of that nature.
Any last questions or feedback? Okay. Well, thank you all for coming to our PDR. We really appreciate all the feedback you have given us in our last PDR and this one. We will keep you guys updated on what happens. We'll let you know if the gear case explodes again. You'll see it in the Discord. Yeah, so that's everything. Thank you so much for coming. We will be sending You can find these slides. Do they have the link to the drive?
Yeah, so
Yeah.
in the email that I've been sending out to everyone, there's a link to a Google Drive with PDF of all the PDRs.
Mhm.
Those are gonna be updated at the end of the week with updated slides. And then there's also a link to the YouTube channel where all the videos are posted. And we'll also upload all the meeting minutes to the same drive that the PDFs are in.
Okay. So in case you didn't hear Nat, all of these slides are in the link to the Google Drive. Also, the videos of each of these PDRs will be uploaded to the YouTube, and the PDFs will be sent out again along with meeting minutes at the end of the week. So if you have any more questions or just have feedback that you couldn't think of at this point in time, let us know. We would really like to continue communicating and getting more feedback as we finish up the design process. But yeah, that's all we have. Thank you guys for coming. Huh? Oh yes, tomorrow at 7 p.m. you should all come to the ergonomics PDR. That's
7 p.m.
7 p.m. Eastern time, yes. Same Zoom link. Thank you, Chaz. We know you'll be there. Cool. Okay. Thank you all for coming.
Thanks, guys. Great presentation again.
Great job.
Thank you. Awesome job.